Playing red light, green light.
Simple schoolyard games with a dark and deadly twist. What could possibly go wrong? Okay, so Squid Game probably isn't the best TV show for little kids, but right now, while everyone's talking about it, we wanted to give you a little PG rated taste of the intense action and really cool ideas that are propelling this series to become the most popular Netflix show in history. This week we took a really fun game concept from the show, an intense game of red light, green light, and converted it into a really cool side-scrolling action game for Scratch.
You are allowed to move forward when it shouts out green light. Stop when it shouts red light. If your movement is detected afterwards, you will be eliminated. Green light!
Race against a crowd of AIs to try and get to the finish line first. But don't let the giant, creepy animatronic doll catch you. Red light! This intermediate level coding project is all about timing. And if you follow along with me, you'll learn all about how to use custom blocks and message commands to organize your code into different chunks that do different jobs along the way. If you're new to Scratch, you should probably start with Cat and Mouse, my introductory coding curriculum. It has everything you need to know to get started with the world's most popular coding system for kids. But if you're ready for some demented schoolyard action, let's get right to it. So if you want to code this project along with me, you're going to need a starter file, which is basically a Scratch file that has all of the graphics and the sound effects you're going to use in this program, but none of the code. And that way you can code along with me and see how everything works without having to go through the very time-consuming process of finding or making your own graphics and figuring out sound effects and things like that. So this is really the best way to follow along with this project. You can find the address up above, or you can go down to the file description down below and grab it from there. So I'm looking at a version of the starter file right now. I've added some code to it, which I'm just going to drag onto the screen to save me the time of having to look for it. But let's have a look at what's been packaged here already. I've got a bunch of sprites here over in the right-hand corner. The player sprite, of course. Let's go and look at him inside the costumes here. I've designed this fellow myself, and he's just a generic looking character. He's going to be running fairly small on the screen, so even a lot of the details that I've added to him here won't really be all that visible. Now I've got a ground sprite here, which looks like this, and it's basically just a kind of a steel concrete floor with the Squid Game's logo pasted on it. Now that sprite is created 2 times on my screen here, and that's because we're going to be scrolling it across the screen here. So it's going to basically move as we code here and slide across the screen this way as we move to the right and slide this way as we move to the left. So our character is actually going to be anchored in one place for most of the game, and it's the floor that's going to move sideways to create the impression that we're moving across a bigger play area than we actually have to play with. Now that was a design decision that I spent some time thinking about. The real challenge here, let's have a look at the constructed game board, or roughly what it's going to look like here. The real challenge is that that this red light, green light sequence takes place in a very huge kind of arena. If I was to zoom out so that you could see the creepy doll character at the end of the race course and see your character, we would have to zoom far, far out, and this character would be even smaller than he is right now on the screen, and that wouldn't be very playable. So if we're going to zoom the camera in, we have to basically create some kind of a mechanism so that the character can continue to move around the screen here and the screen will move with him. We still want to see this doll though, so I've created a bit of a hybrid system where the stuff on the right here will stand still and the stuff on the left will move until we get really, really close to the end, and then we'll actually start approaching the finish line. You'll see what it looks like in a couple of minutes as we start setting it up. So as I mentioned, we've got a whole bunch of other graphics here. We do have the creepy doll figure here. I've separated into a head and into a body. This character was designed by my wife Lynn, by the way, who's a bit of an artist, and she's done quite a lovely job with this. She also designed the creepy guard figure here, which is really a copy of the guards from Squid Game, but seen from a top-down view. I've got an AI figure here that's just basically a copy of my main character, and I've got a couple of other bits and pieces here, including thumbnail files. So I've got a nice thumbnail design for the game here, and I have a win screen that shows you collecting money in the background, and a game over screen that shows another view of that dangerous doll here. So we're going to start with a green flag here, but that's not going to stay on this chunk of code forever. We're going to take most of the stuff that normally happens under the green flag today, and we're going to put it under a message command. And the reason for that is so that we can restart the game without clicking the green flag. If we initialize our variables and do all that other housekeeping stuff here, if you try to replay the game by clicking on the game screen, all of this stuff that happens under the green flag will be ignored, so we don't want to do that. We're going to rearrange it later, but right now, while we're getting everything up and running, we'll just use the green flag and we'll sub it in later. So I'm going to grab a few variables here, and this will just get us set up here. I don't want to have to code all these individual pieces. So we've got two variables here. These are all global variables, by the way. I've got a y speed and x speed variable. And the way this works is, rather than pointing in a direction and moving the way you normally would in a Scratch game, we want to move across a virtual screen. The screen is actually way bigger than the 480 by 360 pixel screen that we normally see in Scratch. And so to do that, we're going to have to create these virtual coordinates so the thing can go right off the screen and go to a x coordinate of 1,000 or minus 1,000 rather than going to being stuck within this tiny little world here. So to do that, we're going to have to create some new variables that control our speed and our position. So what's going to happen is we're going to set up how fast we're going across the screen with our x speed, how fast we're going up the screen with our y speed here, and every turn we're going to look at that speed and we're going to move accordingly. So if my y speed is 2, we're going to move up the screen. If my y speed is -2, we're going to move 2 pixels down the screen, just like that. All right, I've got a friction amount here. When you stop moving, you still keep moving for a while, and that's what the friction's about. It'll stop you. It'll bleed your speed away slowly as you're moving across the screen, and that'll make the game a little harder, because when you think you're stopping, it'll actually take you a half second or so to actually stop, and that'll, because this is a game about timing your movements, this will mean you have to be a little more cautious, because even if you think you've stopped in time, you have to leave yourself some time to slow down. We've got a max speed, and that's just our speed limit here. So 5 is the maximum speed. You'll be accelerating as you move and going up to a maximum speed of 5. Player X and player Y are just like your X and Y coordinates of the game, but as I said, they're virtual, so they could be far bigger than the actual size of the screen here. So you could have a player X of 1,000, for example, and the computer won't really blink at that with this system, and that's something you couldn't do unless you were doing this little more complicated system that I'm going to show you today. Distance is a variable that's going to show you how far away your character is from the end of the screen, where you're going to be trying to race to get across this finish line to this creepy animatronic doll. So that's actually going to be a big variable. Let me show it right here, right now. We'll just make it view. So we've actually got the word distance written out in type here. I'll just make that visible. And so as you move closer to it on the screen, this variable is going to go down. Actually, I did some play testing, and I've decided to go with a variable of 100 rather than 200 on the screen here. So let's just fix that right now. There we go. So we want our character to be kind of facing the direction he's moving, but we can't use a point in direction, again, because we're going to be changing player X and Y, but not really changing it using the normal system inside of Scratch. So I've set up a different variable here called facing direction, and he's going to be facing to the right now. You'll see how that'll work in a little bit. I have another variable here called a red light, and this is going to be set to 0 when it's not a red light, and 1 when it is a red light. At the beginning of the game, though, there's no red light, there's a green light at the beginning of the game, but we don't want your character running until he actually gets the go signal to start the race. So just for now, I've set red light to 2, which will be neither red nor green, basically, and that'll just get him into a holding pattern until he gets that go signal, and then he's allowed to start moving. Okay, a few other things we have to set up before we get started with our game here. Number 1, we're just going to point our character to the right. As I said, we're going to be using a different system to change our character's facing, but right now we're just going to position him properly. The other thing we want to do with him is get him set up to a starting position, which is an X of -140, which is right here on the screen, and that's where he's going to be glued for most of the game. So the floor is going to move underneath us, but for most of the time we're going to be sitting here and not appearing to get any closer to this end until we get to a distance of around, I think about 15 or so, and then we're going to start moving closer to it. We've got clear graphic effects here, which just gets rid of the ghost effect and the glow effect that we're going to be using on our character later. We might not be clicking the green flag, as I said. We might be restarting the game by just clicking the screen, so we have to make sure those things that are normally cleared out when we click the green flag are done properly. We've got an idle animation here that our character should start off in. Let me show you my character again. So we've got him just kind of standing around like this, and we have a couple of different walking animations for him as well. I just designed this character quickly myself, and it'll do in a pinch. I'm sure if you guys are more creative, you can probably come up with something that works a little better. And we're just going to move him to the front of the screen here. We're going to be doing a lot of that. There's a bunch of different layers here, and so we're going to be moving them around to make sure that everything is stacked up properly with themselves. Okay, so next we're going to set up our keyboard inputs. We're going to want to start doing this forever. Now this is another part of the program that, again, we're going to disconnect later on and add to an event. But for now, let's just keep it under the green flag just so we can test our program out as quickly as possible. So we're going to be doing keyboard inputs. Let's start with the W key, which will move us up. I've already got this prefabricated here, and let me explain what's going on in here. So I'm going to go with dual keyboard options. Some people like WASD. I'm a big arrow key fan myself, so I thought I'd give you guys the option. So we've got an if statement here that says if key W or key up arrow pressed, then we're going to move up the screen, and we're going to do that, as I said, by changing the Y speed. So we've got another if statement inside here. We could say this or that and this other one, but I'm just going to keep it simple by putting an if statement inside my other if statement here. So if I'm pressing up on the keyboard, and if my Y speed is less than that speed limit, the max speed, then I'm going to increase my speed here. So it's going to go up one at a time, and that'll give kind of an acceleration effect where it starts off slow and gets faster. You can mess with these speeds if you like, with the max speed and Y speed variable to change the acceleration and the speed limit if you like, but I've played around with it, and 5 and 1 seem to be pretty good. And set facing direction to 0 right below here outside of this if statement. So regardless of whether he's at the top speed, if we're pressing up, we want him to be facing at an angle of 0 straight up the screen here. So that's why that's outside of this if statement, because it doesn't matter whether he's at his speed limit or not, we still want him facing upwards here. So if we click the green flag now, nothing much is going to happen. We're not quite there yet. We're changing variables around here, but we're not actually going to be moving across the screen, as I said, in the traditional way. We are going to be able to go up and down the screen. Originally, I had set this up so that the game scrolled up and down as well as left and right, but I realized that it just hurt the playability of the game, because there was this exploit you could use where you could go up above the AI characters and get around them without having to worry about bumping into them. And so what I've done instead is created a long, incredibly wide field here, but the top and the bottom will just function the same way as normal. So when you move up, you actually will move up the screen and move down the screen, but the left-right motion here will be the floor moving underneath you. Okay, so we're going to do the rest of the directional keys here, which aside from a few little differences are mostly going to function the same way. To go downward, we're going to go if our S key or down arrow key is pressed. Now notice that the next line is a little bit different here. Our if statement has an absolute value in it. Remember, absolute value is a block that you find down here at the bottom of our green blocks here. And absolute value just takes a negative number and turns into a positive number. And it takes a positive number and leaves it the same. So it just basically strips the negative sign off of a number. That's important because as we're moving down, our y speed is going to become a negative number. We want to compare that to our max speed, which is always going to be a positive number, 5 in this case, right? So we want to see if that speed, -2, -3, -4, is less than the speed limit of 5. So we have to strip the negative off of it. -3 is still under the speed limit, but -6 is too fast, or moving down at too fast a speed. So we're going to want to limit that. So that's why we need the absolute value here, so that if our number gets down below, so to make sure that our number doesn't get down below -5. So this is going to cap it at -5 here, and we're going to change that y speed by -1 each time. So it'll slow us down if we're moving up and then start accelerating us in the other direction. We're going to set the facing direction to 180, which makes a lot of sense. All right, the next line, we're moving left and right here, and we're doing the same thing, basically. So for the left arrow key, we're going to go absolute value over x speed, because we're going left into the negative numbers. If that's less than the max speed, then we're going to change our x speed by -1. And we're going to set our facing direction to 270, which is facing to the left in Scratch World. And for the right-hand key here, we've got if, and in fact here we don't need the absolute value here this time. We can just go if our x speed is less than our max speed, then we can change our x speed by 1. And we'll set our facing direction to 90, which is facing to the right. Okay, so now that we have our speed set up, we have to change that speed into motion. So as I said, in the case of moving left to right, we're going to be moving the map left to right. So we're going to set our new player X position and change it by whatever the X speed is. So if we're moving 2 to the left, our character is not going to move 2 to the left, our map's going to move 2 to the right. And I'm going to show you that in just a second, but because the Y is a little bit simpler, I'm going to show you that first. So we don't need to do this same structure for changing the Y because we are actually moving up and down the screen. So we're actually going to change our Y value on the map by our Y speed. So we're going to actually literally move up or move down depending on what the speed is here. That's going to cause some problems though. So we can't test the left-right movement yet. We're going to test the up-down movement, and you're going to see there's a little bit of a bug here. So if I hit the W key to go up, it goes up, and if I go down, it goes down, up, down, up, down. You can see that it kind of accelerates. But if I accelerate too fast, and my speed gets up to 5, it just keeps going, and now it's frozen. It refuses to go any further. And the reason for that is, so I'm hitting the up arrow key, and my speed, let's go find my my Y speed and have a look at that. And that is in fact 5 now. So 5 is not less than the maximum speed. It's equal to the maximum speed, and that means that it's refusing to go up or down any further because that number is equal now to the maximum speed limit. Now that would normally be a problem that we'd have to code around, but one facet that we haven't added to the system here yet is friction. We're going to want, once we let go of the key, for our speed to start bleeding off again. So very quickly our speed's going to be below 5. It's only going to stay above 5 until the moment that we let go of the W key, and then it will start to subtract itself, and then we'll have our controls again, and we'll be able to go down the screen. Okay, so to implement friction, one of the things we're going to do here is keep everything nice and tidy. We're going to put the friction inside its own little section here, so we'll be able to find it again whenever we need to, and we'll make the code a lot more understandable to people who are looking at it later. So I've gone ahead and made a custom block. You guys will recall that to make a custom block, we just click on the Make a Block button under My Blocks, And that gives us some options here. We can give it a name. The rest of these options, including run without screen refresh, we're just going to keep these all the way they are, and we just have to go ahead and name this friction up in this window here. I've already done that though, so here's my friction script. So we're going to implement this friction, bleeding off a little bit of speed by using some if statements here. So let's grab the first one here. If y speed is greater than 0, so if we're moving up the screen, and that will mean our number here will be positive, then we're going to change our y speed. We have to bring it down to a negative number. We have to make it go down. So we're going to take that friction amount, which is 0.3, and we're going to multiply it by -1, which will just convert it to -0.3, and that'll bleed a little bit of speed off here. So that's good. That'll start bringing it down if our speed is up. And we can do the same thing in the opposite direction here. So if our speed is less than 0, if we're into negative numbers, then we're going to want that speed to go up until it gets close to 0 here. All right, so we can test that now, and at least our y coordinate should be working properly now. So we're going to click the green flag, and you can see that when I move up, it moves up, and then the speed starts bleeding off. And even when I get it going at its fastest speed, 5 or -5, it's still responsive now. So we've solved that problem. There is another little bug. You can see that there's a little bit of speed left. That's because our number isn't divisible properly so that it goes down to exactly 0. We're bleeding 0.3 off. And so we'll want to correct for that in a second. But let's get our x coordinates set up properly first, though. So we're going to do the same thing for our x. If our x speed is less than 0, we're going to change our x speed by the friction amount. And if our x speed is greater than 0, we're going to want to do it in the opposite direction. So we're going to multiply that by -1 again. Okay, so when our speed gets down very low, like below 0.5, we're just going to want to correct by bringing it right down to 0 at that point. And I have 2 more if statements here that are going to accomplish that. So right below the other ones. So if the absolute value of our speed, so regardless of whether we're negative or positive, if we're within 0.5 of that 0 number, then we're just going to call it 0. We're just going to set it right to 0, and that will correct that little drifting motion. And you can see that our number always goes nicely down to 0 here, no matter what happens. It's a nice smooth motion here. It doesn't look natural for you to stop immediately when you let go of that button. You want it to drift a little bit further, and that helps with the play mechanic of this game, of course, because the goal here is going to be to try and stop at the right moment, and you're going to want to make it a little trickier by having yourself move. Now this happens in the real red light, green light game, where you're moving and you've got a certain amount of momentum, and then if the person you're playing against turns around really quickly, he will spot you move. He or she will stop you, catch you moving without you having a chance to stop. So this kind of models the real life uncertainty of stopping a little bit better than simply having us change our XY coordinates when we move that key. Okay, let's move on to the horizontal movement, which I said is a little bit trickier. So as you see here, we're changing our player X by the speed, but we're not actually changing the X coordinate of the player. We're just changing this value. So we've got to go over to our ground and have it respond to these changes to the player so that our screen starts scrolling the way we'd like it to. So let's go over to this sprite over on the right here called ground. Let's not look at ground 2 yet. Make sure it's ground 1 you're coding in here. And so we're going to start with the green flag. We're going to substitute that later on with an event, but for now we're going to leave that there. Our x coordinate is going to change, but our y coordinate is always going to be 0. We're going to be centered here vertically on the screen. We're always going to be at the back, of course, because this really is a background level on the screen. We're going to set drag mode to draggable. That's not a block we use very often. It's over in sensing here, right in the middle. Set drag mode to draggable. And what that does is stop players from accidentally dragging that sprite across the screen. You can't really do it in full screen mode, but if you're playing in the editor mode, you can sometimes just accidentally drag stuff across the screen like that. And look at that, I messed up the layer stacking order here while I was doing that. Okay, so now let's go grab a forever loop, and here's where we're going to actually start modifying the location of this background. So we're going to set our X here. We're just going to constantly keep updating it based on player X. So we're going to do a subtraction here. So we're going to go 0 minus player X. And so what that's going to do is, let's say our, so this thing's home base here at the start of the screen is 0. And we're going to subtract whatever our X is. So at the beginning, our player X is at 0, and we're at 0 as well. So this thing is going to be centered right on the middle of the player here. So not actually in the middle of the screen, but right on the middle of the player here. And then as we move to the right here, our player X is going to increase. So let's say our player X is 10. That means that 0 minus 10, it becomes negative 10, which means that the screen's going to move 10 to the left here. And so it's just going to constantly keep moving to the left. So let's try that out here. I'm just going to show you. So as I move to the right here, you see that my screen moves to the left. And as I move to the left, the opposite happens, and my screen moves to the right. We run into trouble here, though, when I go a little bit too far, because I reach a point where my object goes right off the screen here, and it doesn't want to go any further. Scratch doesn't want to position things off the edge of the screen, and in any event, it's not going to do us any good over the edge of the screen here. So what we really want is for this to pop over to the right-hand side here and start over again. So once it reaches this point, we want it to go back here again, and then start moving to the left, and then go back and do it one more time, and keep moving to the left across the screen to create that illusion that that we're moving. So to do that, we could do an if statement. We could say if player X is greater than 480, which is the location off the edge of the screen here, then move it to this new location off to the right here. Sorry, if it's more than negative 480 anyway. But an easier way to do that is using this command called mod. Now, I've talked about mod before. It's a really useful little thing if you're going through lists where you want something repeating over and over again. Let's say you want a computer to count to 10 and then go back down to 0 and count to 10 again over and over and over again. What mod does is, if whatever number you enter in the right here is going to be the maximum number that any variable can get up to, whatever the variable that you're modifying is going to be. So in this case, we're going to be modifying this value here, which is 0 minus player X. And as soon as that number gets past 480, it's going to go back down to 0 again. And what that will do is automatically pop it over to the other side of the screen. Let's put that in there and see what that looks like. So when I go off the edge of the screen, you'll see that it'll show up on the other side. And it'll go back to its center position again and start moving from there. And it'll work in the opposite direction as well. Now you can see we're still not working properly here. That's because half the time this thing is off the screen, and we're just seeing the white background here. So that's no good. What we can do, though, is add a second piece of background here that's identical to the first. And so, and we're going to offset it 480 pixels to the right of this one, so that whenever this one leaves a little bit of a gap, it would be filled up by the other guy who will take its place. So between the two of them, they'll always have the entire screen filled. And so to do that, we're going to use basically the same code. I'm going to look at ground 2 now. And you can see it's the exact same code, except this last block here, we've added minus 480. That's what's going to offset it from the original one. So when I pop that in there, okay, so when I press the green flag and max my screen out here, you're going to see that this background is going to almost magically just keep recycling itself. No matter which way I move, left or right, you're seeing that that background just keeps recycling itself. Now, part of what sells this illusion is the fact that the right-hand side of my image almost perfectly matches the left-hand side of my image so that they seamlessly tie into each other one after another. I set that up that way in Photoshop, and it's something you do have to be careful about. You can see a slight seam here where it's not quite right, and this, you can see this is the edge of one and the start of another one, but it's pretty darn good anyway. So that does it for the background. It's actually, once you understand this code, it's not actually that complicated to do this. And we can do this even in 4 different directions, as I said, which was my original plan here. Now, there's a couple things that are making this look a little less realistic now that we can fix pretty easily. Number one, our character has to be facing in the direction we're moving. Otherwise, he just looks like a Pong character sliding up and down. We also want to change his animation so that he appears to be walking around. So let's tackle this one thing at a time. Let's start with direction of movement. So I'm back inside my player sprite now, where you might recall every time I hit a directional key, we change this variable called facing direction around. And so if we want our character to point in the direction that our keyboard is moving, all we have to do is change our facing to match this variable. So I'm going to do that inside another custom variable which I've already created, and that is called rotate characters. So if you grab that and put it right underneath our friction here, then we can go down to the define block and tell it what to do. So I'm going to go grab this block that says point in direction, and we're going to fill that up with the variable facing direction. And now you see that no matter which way we face, we're going to rotate our character to face that direction. Now there's only 4 choices, which isn't really ideal here. Now again, as I said, we can use some complicated math here to get those intermediate directions figured out. But because we're trying to keep this tutorial nice and simple, I'm going to show you guys a little bit of a hack that's going to work a little bit better here. Let's hide that variable first because we don't need to see our facing direction. All right, so what we're going to tell it to do is if we mash 2 keys at once, we're going to add we're going to get 8 directional movement here by saying when I press up and to the left, we're going to move up at a leftwards angle like that, and if we move upwards to the right, we're going to turn on this angle, etc., etc. So we can do that all just with a series of if statements and keep it really simple. So we start off with this one here that says if I'm pressing up and left, then I can set my facing direction to -45, which is up and to the left on our screen here. That actually, because of the way that I'm flipped here, I guess it would be more like that, up and to the left towards that corner of the screen. All right. Now remember, we're doing WASD as well as up-down movement, which means we have to take and we have to add. Let me shrink the screen a little bit. We're going to add an OR statement here. So if I press this combination of keys or this combination of keys, W and A, we're going to get the same result here. So let's have a look at that inside the game here. So when I press up and to the left, you see that I'm pointing up in that angle. Okay, so we just have to do that for the other 4 combinations of directions here. So if I press up and right, or W and D, then I change my facing direction to 45. If I press down and right, or I press S and D, we go to 135. Okay, before we test that, there's one little problem here. This point in direction, facing direction here has to happen after all of this is processed. That's why we're not going to get our diagonal movement working properly here. So I'm just going to pick this up and move it to the end of our script here. So it's the last thing that happens at the last time that we change our facing direction here. So let's test that again now. And you can see that when I move up left, down right, yeah, I'm getting some nice directional movement here. Beautiful. Okay, so far so good. Now just a little bit of animation and maybe a little sound effect to show that we're walking, and then we'll be good to go. So we're going to set up a separate program loop to handle just our animation. Let's go grab a green flag and a forever here. And we're going to do an if-else here. We're basically going to say if we're moving, then we're going to do one thing, and if we're not, then we're just going to go back to an idle animation here. Now, I'm going to make this animation change when we move at a certain speed. If we go really slow, I think we're just not going to bother to change our animation. So it's only when we get revved up a little bit. So I'm going to say, I've grabbed an or statement here that says, if our absolute value of our speed, so we're judging this by our speed, our x speed or our y speed. So no matter what direction we're moving in, we'd still want to check both those values, our x speed or our y speed. So if we're moving faster than 3 in any direction, then we're going to trigger our walk cycle. And if we're slower than that, I think we don't really need to worry about changing our animations around. So what we want to do is get a sound effect and a change of graphics going here in this if-else statement. So the first thing I want to do is we're going to be playing with volume a little bit here in case there's other sound effects going. We want to be able to stop this sound the second that we stop moving. So the sound effect I'm talking about here is just called footstep. And it's a little hard to hear here. And you can see that there's 2 footsteps here. And so rather than try to stop the sound here, we're just going to turn the volume down to 0 when we don't need it. And that way we'll get a nice continuous sound effect of footsteps that, that will stop when we need it to. Okay, so we're going to set the volume to 100. And then we're going to play that sound, footstep. And then, because we're starting the sound, we don't have to wait for the footstep sound to finish before we start changing the animation. So we're going to switch costume to walk 1, and then wait 0.2 seconds, or you could change that to 0.2 if you're a stickler, though both will do the same thing. And then we're going to change that one more time to walk 2. And so we're going to keep going around that loop as long as we're going fast enough, and we're going to change it to 1 and then the other and 1 and then the other. Didn't want to go next costume because then we would go through the idle animation too, which of course we don't want to do. All right, and so the else statement, if we're going too slowly, we're just going to set that volume to 0, which will turn off that walking sound, even if it's in the middle, and without killing all the rest of the sounds and the other sprites that might be going on. And then we're going to switch back to our idle animation. Okay, let's have a look at that. And that's looking very satisfying now. I'm liking that. See how I added a little bit of a wiggle to the walk here? That looks very realistic. His shoulders move back and forth as he's walking. All right, that's looking really good now. So our character is looking pretty darn close to done now. The one change that I do want to make, though, is I want him to be able to approach this yellow line. And right now, he's just going to always stay the same distance away. It's going to be a little bit like Alice in Wonderland here. He's just going to keep walking and never arrive at that line. So to do that, we're going to have to set up our distance variable. Let's go ahead and do that right now. Okay, so I've shown my distance variable again, which I made really big using the right click. So by default, our variables look like this. They say the name and then they have a small readout. But if you right click on it, you can get a large readout, which just gives the number. And then we can do the text part up here just using some scratch text. And that looks a lot sharper to me. So we've set that to 100 by default, and we want that to start matching up with our player X. As we move across the screen, we want that to get lower as we move to the right and higher as we move to the left. So we're going to need a green flag here and a forever loop, and we're going to have to do some math to get that in there. Now we don't want the distance to be measured in pixels, so player X changes based on the number of pixels we've moved. So every time we move 1 pixel, player X changes by 1, but we don't want the steps to be that incremental. Otherwise, we'd be done the game basically by the time we moved more than a couple of, more than maybe, 1/5 of the way across the screen, and that's no good. So we're going to have to take that, the number of pixels, and divide it by something so that that number goes down a little lower. Let me show you the formula that we're using here. So we're going to set that distance variable, and we're going to change it to player X over 40. So player X divided by 40. So every time we move 40 pixels, player X changes by 40. We're going to move, that distance is going to change by 1. So we're going to start at 100 and subtract this formula here. So by the time we move our first 40 pixels, let's just simulate this here by going set player X to 40. And so you can see the output of this is now 99. So every time we move 40 pixels, let's try look at what it looks like the second time we go. When we go to 80 pixels, set player X to 80, and you can see now that number's down to 98. And so every 40 steps, that number's going to go down by 1. The only problem, though, is that in between, that number is going to get really ridiculous. Let me show you what that looks like in here. So when I click the green flag, we start off at 100, and then I start moving. We get decimals here. We don't want to see all these weird decimals. This does not add to the realism of our look here. So what we're just going to do is round that number off. So we're going to grab this round block, which we can grab from our operators. It's right down here near the bottom. And we're going to round that to the nearest whole number. And now you can see that our number is going down quite nicely. Now that's eventually going to get down to negative numbers, and that's no good. So we need to basically tell it that when it gets down to a certain number, when that distance reaches a certain number, then we have to start acting a little bit differently. Don't need this anymore. All right, so right underneath the set distance, we're going to add an if statement. And we're going to say if our distance is less than 18. Now I grabbed this 18 number after a little bit of playing around. The difficulty I had here was I wanted to start moving forward at some point, and then to keep moving until we hit this yellow line. And right when it hits that yellow line is where I wanted it to reach 0. So the first time I tried this, I put a different number, something like 10 in here. And then when I reached that line, I ended up being at the negative number. So I just played with this number, tried higher, lower numbers until I found something that worked fairly well. So there's no real math to this. It's just trial and error, basically. So if our distance is less than that 18 figure, which means that our distance variable has reached that number, that means we can start approaching this yellow line. So we're going to kind of turn off the system that kept us frozen in place here, and we're actually going to start moving forward by changing our X value as we approach that. So I'm going to change my X. Now we're going to change it based on the X speed, of course, but again, the X speed doesn't correspond to movement across the screen here. Again, I just kind of played around with the numbers. I'll show you that in just a second here. But I just played around with the number to find a good value. Now I'm going to finish this up here before I test this out. The else statement here is just what if our distance is greater than 18, and that just means that we're going to go back to being frozen in place, which is our X value is minus 140. All right, so let me show you what that looks like. So I'm going to click the green flag. Okay, so I'm walking and my distance number is going down here. You can see I can still slide up and down if I want to on the screen here. And pretty much everything is business as usual. It looks like we're going on forever, but once I hit that magic 18 number, you're going to see things start to change here. And so there's our 18. You can see that we're starting to move forward on the screen now. With every step, we get a little bit closer. Now, what looks realistic and what doesn't for that is the question here. but you can see that as soon as we get to the line here, we cross that 0 number. And again, that was a process of trial and error there that had to do with playing with both the speed here and the distance. So let me show you what happens if we change the speed to a higher number. Let's try 5 or something here, for example. So again, we move beyond that 18 range, and now we're frozen in place. And then as we move closer, you'll see we must start moving more quickly across the screen. And look at that, our distance is off again now. So it's a very careful balance we have to strike between speed and the start time of this animation to get everything lined up properly. So 2.8 worked out quite nicely. If you want to try some different combinations, you do have to change both these numbers to get it synchronized properly. Anyway, and so all we have to do now is have some kind of event happen when we cross the finish line here. Oh, I've got to restart this. So when we cross the finish line, we're going to have to basically have some kind of event happen that is going to let us know that we've won the game. Let's go ahead and code that. We're running out of time here today, but we'll do that one last thing, a little winning event here, and we'll make this seem like the easiest game on earth. We're going to have to add some more difficulty to this, and that, of course, is going to come via this animatronic doll, which we're going to animate next week and bring to life, and we're going to make her able to take out our character. And then, of course, the AIs that are going to be running along with us as well. They're going to pose their own problems for us. Okay, so still inside the same script here, we're just going to add another if statement in here that deals with the winning conditions. And that's going to be if our distance is less than 0, then we're going to broadcast a message that says you win. And that's going to communicate with the thumbnail sprite over here, which is going to flash a winning sort of poster across the screen here, and I'll deal with that in just a second here. First though, we do want to make it so that we can't move, so there won't be any more movement sound effects happening behind this win. And so we're just going to stop everything inside this script. All the forever loops that are going here can all stop. So we're going to stop other scripts in this sprite and this script. Now, for those of you who aren't familiar with it, those commands can be found under Control. And there's a block here that says stop all, and we can change that to say stop this script or stop other scripts in this sprite. And so I want to do both of those. I just want to stop everything inside this player script here. But I do want the thumbnail to keep running, so that's why I don't do a stop all, because we want it to slowly appear here, and we want some music to play and some other stuff, and a stop all would spoil all of that fun. So let's go over to our thumbnail now. You can see, as I showed you earlier, we have a couple of different graphics here. This is the one we're interested in. It says you win, and it's very dim in the background here, but you can see that we have the famous money ball, which is the big $1 million payout that happens when you win the Squid Game game in the TV show. And so we're going to say when I receive that you win, we're going to switch that costume to you win. We're going to now later on we're going to send this to the front using a different part of the script. So I'm not going to add this to this script. We're just going to manually move it to the front right now. It's hidden, but we can show it here. And we're going to play a couple of different sounds simultaneously. I have two different start sound commands, and that's going to make two sounds play simultaneously. First, it's going to be this payout sound, which is actually a slot machine payout sound. Then I'm also going to play the creepy theme music from Squid Game, which you're going to be hearing a lot of at different parts of this game. And that sounds like this. I do love that track. And so put together, they sound a little bit like this. A fitting way to end the game. The last thing we want to do is hide that variable distance so that it's not covering up our screen here. And you can see we that once we hide that we have a click to play again message that's visible here. We're not going to implement that today, but we'll be doing that in a later week. All right, now we want this graphic to fade in. Now this is based on the idea that our graphic will be ghosted and at the front of everything else. So actually, now that I think about it, let's code that right now. So it's not going to quite look like this in the final version, but for this to work properly, we're going to have to attach this to a green flag here. And let's just grab a forever. So we're going to keep going to the front forever. And when the green flag is clicked, we're going to set that ghost effect. So we're going to go set ghost effect to 100, which is going to make it totally invisible. And then we're just going to slowly fade it into sight by changing that ghost effect by -5 every time. So we're going to do that 20 times, and then the thing will just suddenly appear. And we're going to wait 10 seconds. And if you're still running the game at that point, it'll just switch back to the original title screen again, just to make things look extra pretty. Okay, so let's run that one more time now. So we'll click the green flag, and we don't have our distance variable visible right now. That's going to be fixed later on in the game, but let's just turn it on right now. And we'll just run that distance. There we go, and we cross the finish line, and we get our "You win" screen. Okay, so that is a very simplified version of the game with no opponents in it. So we're going to make this a whole lot harder by, first of all, having the animatronic doll come to life. That's what's going to happen in our next part. And then we're going to do a few other things, and I think this is going to end up being a 3-part series probably. And in our final part, we're going to add some AI characters to the screen. We're going to have a whole lot of similar characters running this little race with you, and we're going to be able to bump into them and have them mess with us as we're moving around as well. So it's going to turn into more of a red light, green light game as that goes on. But first we'll start off with the doll, who definitely needs to get some love here. She's a very, very creepy figure, and I'm looking forward to getting her going. So that is it for part 1 here. I hope you're enjoying this. If you like these tutorials, please like and subscribe to my channel. I just love to get feedback from students, so leave a comment as well if there's something you like or something you'd like to see us cover in the future. And I hope you enjoyed this. We'll be back next week with part 2.